Hello, it's Mr. Claudia here, and today we're going to be going through section 5.6, which is all about power. Power is a word we know from before we learned physics, but in a physics context, power always involves time. So it's energy transfer over a certain amount of time. And that's how we know if something's very powerful. Like in the lecture slides, you'll see a Lamborghini is very powerful because it can do the same amount of work, the same amount of energy transfer, but in a very short time compared to like a smaller car. So let's look at the power, and we'll start with Serena Williams doing a powerful serve, a tennis ball. So we have the time that's here, that's 0.25 seconds, and we know the work that she's done, the energy transfer, whatever you want to call this, work, energy transfer, that's 85.6 joules. So I know how much energy she gave the ball. I know how much time. I can use my power formula. It's work over time. So 85.6 over 0.25. Be careful with the units. This should be in joules. Work should be in joules, or energy should be in joules. Time should be in seconds. 85.6 divided by 0.25. 342.4 watts. The watt is the unit of measure for the joules. It's for power. It's basically joules per second, but we gave it a nice name after Watt, who was a scientist who worked on engines for trains. Okay, let's look at another example. A crane lifts a crate with a mass of 125 kilograms up a height of 14.3. The job takes 3.5 minutes. This reminds me a lot of the question from our last lesson where we were looking at a helicopter. So I have a crane, there it is, and it's got, it's got some rope here, and it's gonna pull a crate upward. So it's gonna start here, and it's gonna move it up to this height. Okay, so what we could do is say, okay, well here it's EG1 is 0, and here we have EG2, which I can calculate, mgh. The mass is 125 kilograms. The acceleration due to gravity is 9.8, and the height is 14.3. Let me multiply all that together. 125 times 9.8 times 14.3. That gives me 17,517.5 joules. So now I can figure out the energy transfer to the crate. Well, it started with 0, and now it has a whole bunch more. So that was the energy transfer. So I'll say my energy transfer, or work done, is equal to EG2 minus EG1. So that's equal to 17,517.5 joules. So that's how much energy was transferred to the crate. But to know the actual power of the crane, we need to know how fast the crane was operating. Power is equal to change in energy over time. We have 17,517.5 joules, and then we have 3.5 minutes. Now this is a bit of a problem because this should be in seconds. How do I convert minutes to seconds? Well, there are 60 seconds in every minute, so 3.5 times 60 gives me 210 seconds. So 210. Now I divide these two things, 17,517.5 divided by my answer. Oops, you can't see that. 83.4. 83.4 watts. Seems like Serena is a lot more powerful than this crane. I probably have a very weak crane. But we can see how we use our concept of work or change in energy, and then we add it to this pretty straightforward formula for power. I like to talk about power and with electricity, because that's kind of how you know the idea of power. And just remember, this is a good distinction. Energy is something you can hold. It's an amount of energy. You can give energy, or you can drink energy in the form of a Red Bull. Power is constant energy use, so it's how much energy is being used every second. So we can't buy power from the electrical provider, but we can buy energy. When you buy energy, often you buy it in the form of a kilowatt hour. In Ontario, kilowatt hour can range between 10 cents and 20 cents depending on what time of day it is. you would use that energy to like run a dishwasher or a dryer. Those things consume a certain amount of power, a certain amount of energy every second. So a dishwasher runs on its high heat setting for 90 minutes. The high heat setting is 545 watts. How much energy does the dishwasher use? So there's a lot of different units and measurements here. First of all, I know the first one. This is time. This is 90 minutes. The second one, 545 watts. Well, watts are a type of power, right? That's what we use to measure power. So what we want to know is the energy. So we have to work backwards here. P is equal to delta E over time. Or if I rewrite this, E is equal to P times delta T. Now, we want to figure out the answer in joules. Well, remember, this is watts, joules per second. So I need to convert this to seconds then. So this is going to be 90 minutes times 60 gives me 5400 seconds. So I have, and now I find for this question, let's just do it like this. So I have 545 times, well, let's write it like this. Power, I told you, watts is the same as joules seconds. So I can write 545 joules per second times 5400 seconds. Look how this resembles a unit conversion from the beginning of this course. The seconds cancel out and you're left with just joules. If I multiply through, I get 5400 times 545 and I get 2943000 joules. Why do I show you this? Because it's useful if I'm trying to express my answer in kilowatt hours. Use that rearranged formula. Energy is P times delta T. Now, for this to work out, we need power to be in kilowatts. Well, power right now is in watts, but remember, if we were converting to kilometers, it's the same as converting to kilowatts. I divide by 1,000, so this is 545 kilowatts. It's not quite a full kilowatt. So that's going to give me 0.545 kilowatts. And then how do I make sure that it's kilowatt hours? Well, this time should be converted to hours. 90 minutes is 1.5 hours. So multiply by 1.5 hours. When I multiply through, my kilowatt and my hours join together, right? This is kilowatt, technically kilowatt times hour, but we often just say kilowatt hour. 0.545 times 1.5 equals 0.8175 kilowatt hour. These are both ways of measuring energy, but you can see this one's a little more awkward. That's why when we're talking about appliances or electricity in your life, we often use kilowatt hour. Again, kilowatt hour is about 20 cents if you do it during the day, so you can see it costs you maybe 18 cents to run your dishwasher, which is a good deal, I guess. Using this idea of cost, we can actually calculate the energy cost. Now, you guys have on my slide, I gave you the, I gave you the way of calculating energy cost, right? I said take the cost, to find the cost, take the power, multiply by time, and multiply by cost per kilowatt hour. This isn't really a formula, it's more of a reasoning idea. So it's not a formula that's included on your formula sheet. But again, you should be able to figure it out just by using this kind of inline units. It's a lot like a unit conversion. Watch how it works. A cell phone uses 22 watts while it's charging overnight. So 22 watts, well, that's the power. Not very much, and that's good. It doesn't use a lot of electricity. If the price of electricity is 5.2 cents per kilowatt hour, so that's my cost. Per kilowatt hour is 5.2 cents per kilowatt hour. How much does it charge to cost your, so this is cost per kilowatt hour, and this is my cost. You'll find that, well, we know cost should be a measure of money. So we're going to take we're going to take the wattage, measure it by, multiply it by the cost per watt or kilowatt, and then we're going to multiply by time. So let's do this. Cost is equal to 22 watts times, how long do we do this? Well, 8 hours for an entire year. So we have, well, let's do that down here, I guess, first. Delta T is equal to 8 hours for 1 year. So that's going to be 8 hours times 365 days. That's going to give me 8 times 365. That's 2,920 hours per year. So we have our cost, which is 22 watts. Then we have 2,920 hours. And then we need to multiply by the price, which is 5.2 cents per kilowatt hour. Now, let's see if we can do some conversions here. Well, I unfortunately can't cancel out the watts and kilowatts because they're not the same unit. So let me put 1 kilowatt up here. That's equal to 1,000 watts. Let's see how things cancel out now. So watt and watt cancels out. Kilowatt and kilowatt cancels out. Hour and hour cancels out. So my only remaining unit left is cents. Now, let's do the math then. So I'm going to take 22, multiply by 2920, multiply by 5.2. So that gives me 334.048 cents. Wow, that's a lot of money. Oh wait, that's just in cents. How can I convert cents to dollars? Well, again, I would use the same technique for a unit conversion. If I wanted to get rid of cents, I have to put cents on the bottom. Well, I know there's 100 cents in $1. So now if I multiply, these cents are going to cancel out, so my answer will be in dollars. Well, actually I'm dividing by 100, which makes sense. So my final answer is $3,340. That's quite a bit of money to charge your cell phone over the course of the year. Should always try to charge it at school, save a few bucks. Okay, so hopefully you're able to work through some of the power questions. Again, it's a pretty straightforward formula, but then we get into some more interesting questions where you can analyze how much things cost. Until next time.